Alright, so we're going to start do a few video notes here this week, or at least try one of them to see if this will help you have more time to work on problems in class, your homework in class. That way I can be there to help you, and you won't be stuck at home not knowing what to do. So the first lesson we're going to do is something called zeros of linear functions, and this is lesson 3.2. If we review really quickly what a linear function is, or if we first look what a function is, usually denoted by something like a letter, and it says of x. So f of x, g of x, it can really be any letter, but that's kind of how a function is notated. And really, if you remember, a function just describes the relationship between x and y on a coordinate plane. And really, if you go even just basic with it, it says if x is this, then y is this. And it kind of gives us points. Like we can write out, well, if x is this, y is this. And we can figure it out using equations. The linear part of it just tells us that if it's a linear function, it's a function that forms a line. Okay? And that line can be curved, or it can be a straight line. It really depends on the function. So then if we're just going to this zero as a function, this really tells us where the x-intercept of the line is. Okay, so we would see that noted as 2x minus 8 equals y. Let's just say we have this equation right here. Let's just say that was our equation. And then we would say f of x, we want to make it into a function, f of x equals 2x minus 8. And we remember the x-intercept is where y equals 0. If we were going to show that on a graph, let's see if I can show you that. Let's see, just say we had a graph like right here. And x-intercept means wherever something crosses the x-axis. And here's the x, right? Here's the y. So it's crossing the x right here. 1, 2, looks like 3. And we would have the point 3, 0. And you notice that y is 0 because it's right on the x-axis, so it's not going to be a positive y or negative y. Y is going to be 0. So that's why the x-intercept, with the x-intercept, the y is always 0. So then if we look a little further, we can we can figure out where this equation, the x-intercept is, by making y equal to 0. That's kind of what we're doing here, and then solving it. If we looked at this equation, we would see, if you remember, if we have something that says f of x equals, what do we have, 2x minus 8, we would just make y equal to 0. And this f of x is really saying y. So then we'll say y equals 2x minus 8. And then if it's the x-intercept, this y is going to be 0. So 0 is 2x minus 8. And then we would figure this out. We have to add 8 to both sides. We have 8 equals 2x divided by 2. And 4 equals x. Okay? And then, so x is 4, and y is 0. If we then tried to graph this, we could check it and see if it is true, which is a really wise thing to do, actually. Sometimes we make mistakes. I know I do when doing these. And so if I just did this graph, what I can do is I can just put in different numbers and see if they come out to where it does cross 4 and 0. So I can make a table. I could say I could do about x, y. Make a little table here. I could say x is 2, x is 0. That'd be my y-intercept. X is negative 2. And then I could just plug it into the equation. So then if I have the x equals 2x minus 8. And then I could just change this to y because that's really what it equals. So then y equals 2, and if I have x equals 2 minus 8, and we have y, oh, I'm showing you, y equals 4 minus 8, and then y equals negative 4. So I have that one. And then I could do the next one. F of x, we're going to make it equal to 0. So 2x minus 8. And we'll make this y, make x equal to 0. 2 times 0 minus 8. And then that's going to cancel, right? And y is negative 8. And then we can make x equal to negative 2. Let's bring this up. So we're going to say f of x equals 2 times negative 2 minus 8. So minus in there. And then we'll call this y. It's negative 4 minus 8. Do the thing where we add this, change the sign, add y equals negative 12. Okay. And then we would just plug these into the graph. Okay. So 2, 1, 2, a little further down, 1, 2, and negative 4. 1, 2, 3, 4. It's right here. And then 0, and really we just need 2 actually. If we just go 0, negative 8, 4, 6, 7, 8. Right? And then we can just graph this. You don't have to worry about the second one. It's always nice to do an extra point, but we're not going to worry so much about that. And we draw the line, right? You see it crosses about right here. And we'd say 1, 2, 3, it is. It's 4, 0. Okay. So that's kind of how you do that. Finding the x-intercept or when y is equal to 0. It's a good example of how to do those. If we look at another example here, you could do, find zeros by graphing. Okay. Sometimes you'll notice when you're doing these, you'll find that you might stumble over the answer or finding the x-intercept. So here I have this f of x equals 3x plus 3, and I just started with negative 1, 0, and 1. I just plug in a negative x, a 0, and a positive x, and then it gives me 3 points, and I can graph the line. And sometimes you see, as I did here, as I solved these out, for negative 1x, I got 0y. And that really tells me right away that that's my x-intercept. And I did the other ones just to make sure I was right. It's always a good thing to graph at least one more line. So when I did the x equals 0 over here, I solved it and I got y equals 3 for that. And then I did 1, x equals 1, and I solved for y, and I got y equals 6. I plug each one in, negative 1 and 0, and then I plug in 0 and 3. This is 0, 3. This is negative 1 and 0. And then this is 1 and 6. And you see, when I graph it out, even if I didn't do this bottom one, when I graph it out, it crosses at negative 1, 0. And that tells me where the 0 is, or the x-intercept. It's another example. And keep going. Another example here. If I, maybe I have 2x minus 2. I think this is one. But if I did this one, I would, again, maybe stumble across it. And I do. So I have to pick these ones. And there it is again. There's the y. Y equals 0, so that's the x-intercept. But then I always, again, want to graph it. So I do x equals 0. I get y equals 2. And then you just follow it on through this here. And then x equals 1, or the function equals 1, I plug that in, and I get 2 plus 2, I get 4 for that one. And then again, I graph it. I have negative 1, 0, right there. I have over here, I have 1, 2, 0, 2. That's my y-intercept, right? Figured that one out too. And then I have 1, 4. here. And if I just graph it, I would again see that I crossed through right there, and that gives me the 0 or the x-intercept. So that's kind of 3 examples of how to do these. And perhaps you want to look at a real world example, as it's going to do in your book sometimes. So here it gives you downloading a movie. It says the function for this process is y equals 1.5 minus this big 0.0625x. Okay. And this tells you the number of gigabytes left after x minutes. Okay. So obviously it looks like you start with 1.5 gigabytes, and then over a certain amount of time you lose, after each minute you lose this much, and you can figure out exactly where the 5 would be 0, right? And that's where we'd use the 0 thing. So we're looking for when does it cross and become 0 on the x. Okay. The question is how long will it take to download the entire movie. So then we just want to pick like maybe 3 points, make ourselves a table, and maybe we want to start at 0 where we have x is equal to just when we start, how much we start with is 1.5, and we can see if we plug that into the equation, right? We get 1.5, and then we take this part right here times 0. That's going to cancel out really quickly, and we're going to get 0, 1.5. I'll show you the graph in a minute. Then we might want to say 10 minutes and 20 minutes. Just pick those. And then we do, so we make the function equal to 10. And this is always going to be when we do these functions, the function, we're talking about, we're saying x equals something, and then we solve for y. Okay? So then the function of 10, we plug in 1.5, and then we plug in the 10 for that. We get 1.5 minus 0.625, and then we minus that out. We're going to get 0.875, and that's what y equals. Okay. And then we have a number, we have 10 and 0.875. That's our set of numbers. And then here, kind of same thing, we just plug in 20 this time, so 20 minutes, because this is just saying after how much you lose the equation is just telling you how much you're going to download or how much is left after 10 minutes and 20 minutes, and the x is equal to minutes, right? So and then we just do the 20, plug that into the function of 20 for x equals 1.5 minus this 0.0625 times 20, and then we figure that out, 1.5 minus 1.25, and then we get 0.25. So then we have 20 and 0.25 is that last part. So then we have our data points. This one we did not stumble across it. Okay. And then if we want to graph this thing here, let's look at the next one. We just took our numbers. I'm going to take this one off and show it to you. You can see it. See the numbers in the data table. So if we have that data table right there, right? And then we're just going to graph these points, right? And you might see my pointer's a little bit off. And this is just kind of giving us a general idea. Okay? And it looks like my data table down here, and I did an x and y. So if you remember x and y is, gigabytes, how many gigabytes. That's what we want to figure out. When is all these gigabytes that we started with going to be gone? It looks like I messed up this right here, so I messed it up. I probably got this down further, like this 1.5. I'm not sure that's right in the middle. I kind of messed up my line, but then I put my points in, and I put in my 0, I put in my 10, and I put in my 20, and then I drew a line, okay? And a little bit off, but it's just because I messed up this part here. But then I see it's somewhere over here. It doesn't really give me an exact point, okay? So then what I can do then is solve algebraically. So it gives me somewhere around 20-some, maybe 25 minutes. I don't know. I'd have to check and see. So then I just solve for 0. And that tells me over the x-intercept is where y equals 0. And you can do this with any of these problems. And so I plug this in. So y equals 1.5 times 0.0625x. And now I'm going to solve for x and see where that crosses. I make y equal to 0. Then I minus, or I add 0.625 to both sides, right? Negative by itself, 0.625x equals 1.5. I divide both sides by 0.625, and then I'm going to end up with the number 24 minutes. So then I know by doing this function is 24 minutes. And that's kind of zeros of functions. You're just trying to find out where y equals 0 or the x-intercept. You can do it many different ways, really two different ways. You can do it by graphing through points like we did right here. And when you're doing that, you might come across the answer as I did here at this one. I can also then graph it and see where it crosses exactly. And it's always best, this last one I did, the gigabyte thing, I didn't do it on graph paper. If I would have done this on graph paper, this one I kind of did on graph paper, but if I would have made a better graph here and really used the half point, it looks like it's down here somewhere, then I would have got this easily. So graph paper, whatever graphing is very important. But you can also always solve for the 0 just by making y equal to 0 and solving to see what x is, and then it'll give you the point. Okay, so that's kind of the notes on zeros of functions. We'll do some more examples in class tomorrow, and I hope this makes sense to you.